This is Simon, a break and remake project for the Interactive Tangible Computing class at the University of Maryland. For this project, we were tasked with finding an existing electronic device, reverse engineering it, and then repurposing its electronics to change the manner in which it is used. I chose to modify a children's toy that I found at a thrift store. This toy has 4 colored blocks that blink and play a noise when pressed. When flipped over, all 4 blocks flash as a sound effect plays. Additionally, the 4 blocks will now play a different sound when pressed. My plan is to turn this toy into a game of Simon. The game will present a sequence of shapes that the user must repeat. With each correct repetition, a new, longer sequence is presented. Inside of the toy is a relatively simple system, controlled by a single circuit board on which there is presumably some form of processing chip. The reverse side of the board, however, is hidden under a layer of tough, black epoxy preventing any tampering. For each of the shapes, there is a micro-switch assembly. As a shape is pushed through the toy, it will actuate this switch with a small plastic nub protruding from its side. Under some tape in one leg of the toy is a small reed switch. This switch is activated by a magnet that slides in a vertical track above it, indicating the orientation of the toy. Together, these 5 switches are the only inputs to the system. The speaker and an LED in each shape are the only outputs. My first order of business is to figure out how to power both an Arduino and the toy. The toy takes 3 AA batteries, meaning that with new batteries, it takes just under 5 volts. This means that once I've powered the Arduino, I should be able to power the toy directly from its VCC pin. And sure enough, when hooked up in this way, everything still works as it should. The Arduino Pro Mini I'm using requires more than 5 volts, and so will need more than just the 3 AA batteries. Instead, I can remove a little bit of the support structure in one of the legs so that a 9-volt battery will fit into it. Now that I've got power sorted, I need to rewire the toy. Originally, a switch detects when a shape is pressed and the processor responds by flashing a light and playing a sound. I want to use one pin on the Arduino to detect when the switch is pressed, and a different pin to tell the toy's processor to flash the lights. My first thought was to disconnect one terminal of the switch and wire it into the input pin. Then I could wire the output pin to a transistor, which would in turn connect to the toy. While this probably would have worked, a simpler solution occurred to me. Since the switch had a 5-volt potential across it, why couldn't I just wire directly into it as is, tying the input and output pins together? In this way, when the switch is closed, the Arduino's input pin would read high and the toy's processor would as well. If the switch is open, but I want to flash the shape's light and play its sound, I can simply drive the output line high, tricking the toy into thinking the shape had been pressed. As long as I don't read the input while writing the output, the logic should all work out fine. I then repeat these connections for each subsequent switch. After a little bit of programming, I close the toy back up and I'm left with the game of Simon. Turning the toy on plays a startup sound, then plays a sequence of 3 shapes. Repeating the sequence back advances the player on to a sequence of length 4. Eventually, a mistake is made. The toy plays a sound indicating this mistake and resets back to a length 3 sequence. So, with a few simple parts, including an FTDI breakout for programming the Arduino, I was able to take a basic children's toy and add a little more interactivity to it. Thanks for watching!